As part of the upgrades to my EV-swapped BMW Z3, at some point I want to add a second battery pack in the rear of the car. This will help with weight balance, but more importantly, give me a bit more range. In fact, double the range, up to about 50 miles. In order to do that, I need to change the way that I switch the high voltages. I want to be able to pull in both packs into one place and then switch that combined high voltage, albeit parallel rather than series, up to the inverter. That all happens in here, or at least it would do. At the moment, I'm using the BMW S-Box, the high voltage switching pack that comes with the BMW packs. Small, neat, nice and compact, but probably not up to the job of switching both packs and giving me a bit more control and a bit more reliability. Hence, I'm going to use a bigger high voltage junction box. Unfortunately, at the moment, that's just a box of bits. This is what my high voltage junction box looks like at the moment. Just a collection of bits. The reason is that I originally configured it before I worked out how to use the S-Box, modify the S-Box, and use that because it's much more compact. I was originally going to use this and actually had this set up under the bonnet of the Z300 until I decided to remove it, use the S-Box and use the saved space for charger. With our new layout, we've got loads more room, and so I'm going back to using this full-size high voltage junction box, in part because it means we've got the space to use big chunky contactors like this, which are less likely to weld and fail on us. And we've got a bit more control in terms of adding things like a shunt, a sort of a shunt for the combined packs, as well as plumbing in things like our heater, our charger director here, although we may still plumb that in to the connections in the inverter at some point. We shall see how much space we have. Originally, this was oriented the other way. Our DC came in here along with our control wires, and out here we had positive and negative and a separate positive connection for charging, because I was going to use the charging capability of the Prius inverter. When I couldn't make that work, that's when I switched to the Outlander charger because it's much simpler, and I've stuck with that arrangement. So we actually only need 2 outlets. None of these are going to be used. These are going to be blocked up, because what I'm hoping to do is have our original BMW connectors come up through the top of the battery box and straight into the junction box, which will mean that there is no exposed high voltage unless 12 volts is on and our contactors are closed. And the same will be true at the back, where we'll also have a manual disconnect, but we'll only have a very, very short run of high voltage wires from here to here that can ever be live unless there's 12 volts. So what that means is I've got to work out a new layout for all this, redo my control wiring, and yeah, sort out all my nice bits of copper that I bent perfectly to fit the junctions, reuse as much as possible, and get it all sorted. So let's get this emptied, let's get the bottom plate back in, maybe cleaned up a bit, and then start to lay things out. Here's what I'm currently thinking. 2 contactors here to ensure that this pack is completely isolated from the other pack when we've got a second pack in. Reason being that if this pack is permanently connected in here, then even if the other pack has a set of contactors in which turn that one off, these wires coming out of here would be live all the time, and that is something we cannot have. So pair of contactors here to doubly isolate the live wires running under the car unless 12 volts is on. These will both close just as soon as 12 volts is switched on, so they'll just be switched on. Notice on the gigawatt contactors you get 4 wires, or at least on some of them. The red and black are your coil, so to engage or disengage it. These ones have a built-in economizer, so you don't need to do any PWM or anything. They just they drop their current consumption right down once they're switched. The blue and white ones are signal wires, so we can actually pull signals out of here to see what's switched. I'd be tempted to put just a little, I don't know, Arduino or something in, connected up to all the blue and white wires, so we can send some CAN bus signals from here, just saying what's switched and what's not. Then we go through the back plane from our S-Box. It's not particularly beautiful, but I do like the idea of being able to unplug this box from everything when I want to work in here with the nice safe BMW connectors. It won't be particularly easy with these contactors in place, but it should be relatively straightforward to just undo a couple of bolts, roll it round. Oh, actually, I'm being stupid here. Why don't I actually just mount it like that? We've got our connections on underneath, so we can just run some copper tabs off here, 3D print some pieces to sit underneath and actually mount it like that, and then we can just pull our cables up. And likewise, we can have our backpack connected in on some cables as well into here, so we can just disconnect front and rear packs from here, and then run out from those connectors out to the rest of it. So yeah, probably mount that like that. Not quite sure how I'd get those screws done up. As long as I've got the copper bits or cables, I mean, they could just be bits of cable bolted to it first, then I can just screw that down. You'll notice these little, if I can pull these off without breaking them. I was experimenting with 3D printed mounts to mount it upright like that, but actually it's going to be much easier just to mount it face down. Maybe put some isolators underneath it, just to make sure that nothing contacts the metal backplate. And yeah, so that will go out to, this is our positive side on the right, and that will, let me get that right, I can't remember which way around that goes now. I'll have to look that up, which way around is positive, which way is negative on the inverter. I'd really like my cables just come out and go straight to it. May rearrange my signal cable so that they're as close as possible just to being a nice straight line. So we've got our pre-charge relay here. That'll go through, this is mocking up for our pre-charge resistor. I've not got a spare one here. Into our main contactor, and then through our fuse and out into positive. And then on our negative side, negatives coming here through our shunt, is a Bell&Hutter shunt, which I've never actually used. I had hooked up, but my cabling went a bit awry. You see that clearly didn't crimp the connector very well because it fell off when I was taking all this apart. So I need to do a new connector for that. That provides information on current, etc. Over CAN bus. That'll go through our next contactor. We can actually just bolt that to there. We'll just need to work out what to do at the other side. And then out to a connector for our main wires. And so our main power cables will just run up there like that. That's the plan. It requires, in my experience, a lot of fettling, tweaking, squeezing, copper bending, wire making, etc. for all that to work. Oh, and the Bell&Hutter shunt also needs a 5-volt power supply, which is, I've just got a little buck converter, basically taking 12 volts down to 5 volts for that. You can see what remains of my crimped connector there. I'm not very happy with all this, so I'll redo some of that. Like, these are terrible cables to do CAN bus with. I'll use some proper multi-strand cable rather than these hard ones, which are very difficult to crimp, and maybe some slightly thicker power wires that crimp a bit better as well. So yeah, that's the layout I'm looking at for that. All a bit messy, but I think I've got this sorted. So I've actually spun the whole box around, and I've shuffled my positive and negative over to the right, so they'll come out of these two holes and go straight up to the inverter here, which means we've got a nice short run to where our data connections or our control connections will come in here. That will be power, which will power everything and turn on the negative contactor. It will be ground, which will just ground out somewhere on the frame. It will be main contactor control, pre-charge relay control, and it will be 2 CAN bus lines to go into the Isabella Hood shunt. And so that's effectively, that's a 6-way connector can go out there. So we can do away with this giant beastie, which I can maybe use elsewhere, and go down to just a much smaller connector out of here. Keep it nice and simple. And then for my sensing lines, I'm going to gather all those together and come out here, I think, because yeah, I think we'll gather all those together and come out here, and maybe then I can just have a little box on top, maybe alongside my battery management system, which will also sit up here, maybe sit at the back so there's plenty of height, which will do contactor monitoring. This does mean I won't be able to put for fast charging later, CHAdeMO, whatever you want to call it. That'll have to be a separate box for those contactors, but that's fine. I can just reuse some of the contactors from the S-box, or maybe even just a whole S-box, to provide my contactors for that. So I'm going to finish drawing around all these bits so I've got a rough location, and then I'll take it back, measure it all up really neatly, drill a load of holes, get things bolted down. Need to measure up for my pre-charge resistor before I do that. But I think once this is all fixed down, that'll be really neat. Need to drill a big hole here for the cables to come up from below, from the battery box. I've already got my holes. I mean, that hole's a bit big now, unfortunately, but I have to find a way of sealing that up for a grommet for my 35mm cable coming in from the backpack into there. And yeah, that didn't take quite as long as I thought to work out, although I'm sure I will change it at some point. Oh yeah, my buck converter for the 5 volts, the Isabella Hood, can just sit over here somewhere. For these sensors, I'll just put them into an input pull-up with one side grounded, and see if they go low, probably through an optical isolator. Make sure there's no interference from the high voltage switching that might damage the Arduino, and then just stick a CAN bus module on the end of that, and then I can just make sure that none of them are welded close, because that would obviously be dangerous. So after redoing the layout of the high voltage junction box and realizing that or rather being reminded that I had those sensing connections on the contactors to see if they were closed, I thought I'd knock up a little test circuit that could monitor the state of the contactors and put the results up on CAN bus, so that I can use that to do things like checking the main contactors are closed before starting charging. I could of course feed all this information to the BMS and extend the BMS, but don't really want to add any more complexity there. Nicer just to have a little separate board that does it, and just 2 wires coming out of the junction box, or rather no more extra wires coming out of the junction box, because I might stick this in there and just add it to the CAN bus alongside the shunt in there. So I've added on this board, I've got an Arduino Uno, I've got an optical isolator because I want to isolate the my board from any connections, and I've got a bunch of switches designed to represent the state of the different contactors. That's all hooked up to a MCP2515 CAN module, and that's connected to 2 other boards, just another Arduino with an MCP2515 for acknowledgement, and then sat in the middle an Arduino Duo running the GVRET General Vehicle Reverse Engineering tool, which hooks into SavvyCAN and allows me to monitor the status of the CAN on my computer. And so now what happens if I press one of these buttons, it changes the data sent in a very rudimentary way on a CAN message and if I do a little screen record...
I don't know that one.
Shush, Alexa. If I show you a screen record, you'll be able to see the output of that. So on the left-hand side of the screen, you've got the serial output of the Arduino, showing the state of each of the switches. And on the right-hand side, you've got the live stream from SavvyCAN, showing the data output on the right-hand side from this particular message string. And so if I now press 1 on you'll press the first switch on here, you'll see that the state changes on the serial. And if you look at the CAN message, you'll see that it's gone from 00 to 01. Now, obviously, I could stick more than the state of one contactor in each little bit there, each little byte there. But this will do for now as a demonstration. Likewise, 2, you'll see that changes. If I press both of them, they both change. And if I press all 4, you can see that all our pretend contactors, if I press all 4, there we go, all our pretend contactors are closed and then open again. So nice, simple sensing of our contactor state punted onto CAN bus. Well, I did say the layout wouldn't stay the same. I realised once I cleaned this back plate up, that if I flipped it over, I already had the holes drilled here for these 2 standoffs, and actually the holes drilled in the right place for these 2 contactors as well, as long as I move things around a little bit. So now I've modified an existing mount for the shunt, so that can sit there. I need to double check that the lid will still go on, but I'm pretty sure it will. I think that's within the acceptable height. I hope it does anyway, because I've just screwed up otherwise. Our pre-charge relay is now going to go there. I need to make another one of these little things. Actually, I could just modify some copper off one of those to create a standoff for our fuse. Need some standoffs for, actually I could just use those again, couldn't I? Ha. Some standoffs for this, and just run some M6 bolts through there, and drill down just a couple of holes to mount that on. And then just need to drill some holes for our 2 contactors for the secondary pack there. Only thing missing is the pre-charge resistor, which is cylinder 300, and I figure that will fit under here somewhere. It's not going to, there's plenty of space in the middle there. It's not going to foul the connectors. It can go lengthways, one way or another. And so connection will go in positive from our front pack into the fuse. From the fuse we'll have 2 connections, one through the pre-charge relay, through the pre-charge resistor, and up to the other side of the contactor. And then once the contactor's closed, fuse out to inverter. Sorry, out to inverter out there. And then on this side, obviously, negative, shunt, contactor out to there. And then just to make sure that there's nothing live going out this side, these 2 contactors will only be closed when 12 volts is on. Well, actually the run. Actually, no, when the car's powered up, then those 2 will close. And yeah, so bit of drilling to do, bit of fettling, and we'll have our high voltage junction box largely sorted. Bit tidier now, and apart from the lack of a bit of mounting hardware, I'm missing some M5 bolts and nuts. I'll have to see if I've got some at home. Apart from that, oh, and I need to 3D print another one of these things here. I've actually made up another copper piece to go on like that, which will hold the other side of the fuse up. And I've got to do some, obviously, the connections from these plugs into here. They're going to cross over a little bit because of the way that positive and negative are, unless I do something funky with the wires that come out of the back box. It'd be nice to have, you know, positive, positive, negative, negative. May do that, we shall see. May do some wire tweaking, obviously make life a little bit easier. Nice is we've got 2 screw terminals on each one of these now, so we can have 1 and 1, 1, 1. Still going to put our pre-charge resistor in, which is going to go here somewhere. Still got to drill our big hole all the way down through into the battery box and make some sort of 3D printed part to make sure it doesn't rub on the metal edges to go through there. But this is now fixed in. Drilled some holes through into the casing, and that's not going anywhere. So that's that bit done, which is cool. I need to sort of extend some of these wires. I need to make up some chunky ones for the pre-charge circuit. I need to get some mounting hardware. I need to get my Arduino monitor thing in here. I need to check that the lid still fits. Actually, I'll have to empty the lid out, but I'm sure that lid will fit, he says confidently. Oh, that's actually quite high, isn't it? Okay, I shall empty the lid out in a minute and make sure that that still fits on there with the shunt upright. So next step, I need to make some mounts for the charger. This is now in exactly the right place. Just need to make and weld up some very simple mounts to sit on there. I also need to drill the holes through from the cover of the battery box into the frame to put some riv nuts in to hold the cover down. Yeah, and then could do to have a think about 12-volt wiring before I wrap this video up. Little more organising. My 80 amp breaker for my power steering pump can actually just sit really nicely there. Just run some screws straight into the plastic behind it. Maybe with a nut on the other side if I can get behind there with a nut, a lock nut. So that can just sit there, and then I can just shorten, well, this cable I can just stick a short termination on, and it can go to an earthing point somewhere on this frame or down here somewhere. This frame or down here somewhere, probably on this frame actually. I'll probably put an earthing strap to this frame and then earth all this stuff to the frame. And then my 12 volts will go to the breaker, and then my control wires I'll separate out. The ones that come here, I only need 2 of those, and those can run through one of these glands up into here. And same for the power for that. That just needs 12 volt and earth, so that 12 volt cable can run up to a fuse in here via the pressure control switch, which I'll get wired in a bit. I'll probably 3D print a nice surround for this. Don't really want to be shorting that out to anything, given that it's at 12 volt battery current. But it's a nice useful thing to tie into. That's also where our DC to DC will tie in. So we'll run cable around there and up here alongside the breaker. Maybe even tie in at the same point, actually, we shall see. Could tie in actually on the top of the breaker where that connects, or could just have another entrance onto here and tie in straight to there. That'll have to wrap it up for this video. Never make quite as much progress as you'd like, but we're getting there. So I've got a little bit more welding to do now that these mounting brackets are made up, and one on the back as well. I'll have to weld those in for the charger. I've still got to put the riv nuts in to hold the case together, the battery box lid on. And obviously we're missing a load of bits in terms of mounting hardware, etc. To finish up the high voltage junction box. But in reality, what I'm thinking is might as well do all that on the 300. So next video, I will pull all this out, make those final tweaks in terms of welding things on. Also need to put on a bracket for the coolant bottle, coolant reservoir. But I'll pull all this out, clean it up, final welds, and get at least one coat of paint on this week, and get a coat of primer on, and then a coat of paint next week while I'm dismantling the 300, and then start to swap it all over, wire, plumb, get the 300 up and running with the new motor. So very much doubt I'll finish that next week, but maybe the week after we'll have that car running with all this hardware. We shall see. Anyway, if you like this stuff, please do like and subscribe. Hit that bell so you get notifications when new episodes pop up. All questions, comments, feedback, really enjoying that still, so keep that coming. Thanks for watching.